Okay, today we're going to look at other types of regression. So in the last two lessons, we talked about bivariate data sets with lines of best fit. So what we did was we looked at scatter plots, we drew in a line that best fit all those data points, and then we did a linear regression to come up with the equation of the line of best fit. But there's oftentimes there are scatter plots or real-world scenarios when the data doesn't fit a nice line or a line of best fit. And in those cases, sometimes they might fit a curve, and we can talk about exponential curves that they might look like, or quadratic curves. Now there's many other curves that the data values would look like, but for this year we're going to focus on linear, exponential, and quadratics. So what we're going to look at today is doing exponential regressions and quadratic regressions, and they are done in very much the same way that linear regressions are done. But you have to remember that exponential graphs are the ones that increase very quickly or decrease very quickly, and the equation of the exponential function is y equals a times b raised to the x. In a quadratic function, we have a parabola, and the equation of a quadratic would be y equals ax squared plus bx plus c. So in our scatter plots, if our scatter plots look like a parabola, we would do a quadratic regression, and if our scatter plots look like a exponential growth or decay, we would do an exponential regression. So in exercise 1, for each scatter plot shown below, we're going to determine if its best fit is linear, exponential, or quadratic, and then we're going to draw a curve of best fit depending on the choice. So if I look at example A, if I were to draw a curve in that fits a lot of that data, that would not be linear, this one would be exponential. So what I want you to do is try the next 5 on your own and see if you can draw in the curve of best fit and tell me what kind of curve you would have. So go ahead and pause the video. When you come back to the video, I'll have the curves complete. Okay, so in exercise 1, option B, or for choice B, we have a quadratic scatter plot. For C, we have exponential. D was linear, E was linear, and F was quadratic. And notice that my curves, the ones that I drew in, did not fit the points exactly. It was just curves that best fit many of the data points. Okay, so now let's take a look at some examples. In our calculator, we're going to use regressions just like we do linear regressions, except this time we're going to do exponentials of best fit or quadratics of best fit. So in the first example, we're going to compare the file size in megabytes of a computer program and its version. So in the first version, there was 155 megabytes, in the second version, 240 megabytes, the third version, 387, and so on and so forth. Part A, look at the scatter plot on your calculator to determine if you should use a linear, exponential, or quadratic regression. So again, what I'm going to do is I'm going to pause the video. I want you to come up with the scatter plot on your graphing calculator. Remember to turn your stat plots on and do zoom stat, and then see if you can figure out what type of regression we're going to do, and then we're going to actually walk through the regression. So go ahead and press pause to take a look at the scatter plot on your graphing calculator. Okay, I entered the data into the lists, and I did my scatter plot. Remember, you turn on your stat plots by doing second y equals, and you turn your plots on, and then you do zoom stat. And that will give you your scatter plot. And what I want you to notice is those data points start going in a curve. They start increasing very rapidly, which means exponential growth. So now what we're going to do is we're going to write the regression equation, rounding all values to the nearest hundredth. And this, like I said, is done in the exact same way a linear regression is done. So I'm going to hit the stat button. I'm going to go over to calculate. And rather than doing a linear regression, option 4, I'm going to keep scrolling down, and I'm going to do an exponential regression, which is option 0. Now our data is in L1 and L2 for the X list and Y list. We don't have a frequency list, and we're not going to store the regression equation. So I just go down to calculate. And what I want you to notice is there's the general form, y equals a times b raised to the x. Caret means exponent. And then they give us the value of a, and they give us the value of b. And remember, we're rounding our values to the nearest hundredth. So 0.699 would round up to 0.70 times 1.60 raised to the x. So that is the exponential model that best fits the data for the version number of the program and how many megabytes it is. Okay, in example 2, it says the cost per widget produced by a factory generally drops as more are produced, but then starts to rise again due to overtime costs and wear on the equipment. Quality control engineers recorded data on the cost per widget compared to the number of widgets produced, and their data is shown below. So notice we have the X value, which is the number of widgets that's produced, and the Y value is the cost per widget. And a widget is just something, some kind of thing that we're going to create. So part A says use your calculator to create a scatter plot for the data and determine if you should use linear, exponential, or quadratic. And then we're going to write the regression equation. So again, I want you to press pause. I want you to take a look at the scatter plot and see if you can determine which regression we're going to do. Okay, so once again, I have my scatter plot up on my graphing calculator, and as you can tell, the data points are starting to make a parabola. So this is going to be a quadratic regression. Now, when we write the quadratic regression, we're going to round all the values to the nearest thousandth, which is 3 decimal places, and again, done in the same way that a linear or exponential is done. So I'm going to hit the Stat button. I'm going to go over to Calculate, and I'm not going to do the linear regression, but what I'm going to do is option 5, which is the quadratic regression, quadreg. Again, the data is in L1 and L2. We don't have a frequency list. We're not going to store the equation. So I'm going to go down to Calculate. And again, what I want you to notice is they give me the general form of a quadratic first in standard form, and then they give me the A, B, and C to substitute. So I'm just going to substitute the A, B, and C rounding to the nearest thousandth. So I'm going to have y equals 0.001x squared minus 0.250x plus 16.863. And that's my equation of the parabola that would best fit the data for the number of widgets and the cost per widget. Okay, moving on to example 3. Biologists are modeling the spread of flu cases as they spread around a particular city. The total number of cases, Y, was recorded each day, X. So X represents the number of days, and the number of cases is the Y. After the total first reached 16, the data for the first week is shown in the table below. In part A, use your calculator to find the exponential regression equation. Now this one's nice because I don't even have to look at the scatter plot. They tell me right off the bat to get the exponential equation. And notice it's in the form y equals a times b to the x, and we're rounding all parameters to the nearest hundredth. So once again, go ahead and pause the video, put your data in L1 and L2, and run an exponential regression to see if you can come up with the exponential regression equation. Okay, when I did my regression equation, I got y equals 15.92 times 1.12 raised to the x. Notice all my values are rounded to the nearest hundredth. Now, for part B, it says based on the regression equation, so not based on the table, but using the equation, how many total cases of flu will there be after 2 weeks? So I want to find the total cases, which is the y, after 2 weeks, which is time. Now, this is kind of tricky because you would think that, oh, you're just supposed to substitute 2 in for x because x is time. However, remember that x is given to us in days. And since they want 2 weeks, that's actually going to be 14 days. So we're going to use our exponential regression equation, y equals 15.92 times 1.12. We're looking to solve for y when x is 14. So raised to the 14th power. So what you're going to do is you're going to enter that in your calculator all at one time. And you should end up with about 77.8. But remember, we're talking about the number of flu cases. And this basically means the number of people that have the flu. And you can't have 77.8 people with the flu. So you would think you would round it up to 78 people. However, we can't round up people. We haven't reached the 78th case yet. So there's actually, at 14 weeks, 77 cases of the flu. So we don't round up people because we haven't reached that 78th person yet. Okay, part C, according to your model, again using the equation, by what % are the flu cases increasing on a daily basis? So we have our model, which is 15.92 times 1.12 raised to the x. And they want to know what % are the flu cases increasing? Now this goes back to having a knowledge of what this number inside the parentheses means and what the number out in front means. If you recall, the number out in front is the initial value. It's the starting amount. So when I started keeping track of the data, I had about 16 cases of the flu. The value inside the parentheses is the B term. That's the growth or decay factor. In this case, because we are increasing our flu cases, it's actually a growth factor. And remember, that growth or decay factor comes from 1 plus R. So 1 plus R is equal to 1.12 because 1 plus R is the growth factor. Now, if I want to find the rate, which is the percent, then I'm going to subtract 1 on both sides. So I have R equals 0.12, and if they want to know what percent that is, that's going to be 12%. So the flu cases are growing at about 12% per day. Okay, option D, hospital officials will declare an emergency when the total number of cases exceeds 200. Now remember, total number is the Y value, and we want the Y value to be exceeding 200. And it says, on what day will they need to declare this emergency? And that means I'm solving for X. So what I'm going to do is I'm going to use my model, and I'm going to substitute 200 in for Y. And I have to solve for X. Now, unfortunately, at this point, we haven't learned how to solve an equation with X in the variable, so this would essentially end up being a guess or check kind of situation. So I don't want you to stress about this one too much. If you spend some time, you're going to end up with an answer of 23 days. But again, this is a kind of a guess and check situation because we've never solved an equation with X in the variables. So what you're going to do is you're going to work on the homework from other types of regressions. You're going to do some linear, exponential, and quadratic regressions for homework.